For decades, students and night shift workers have huddled over counters like this one, relying on a steady stream of coffee to survive a long night. But despite how it feels when that first cup hits your system, caffeine doesn't actually give your body energy. It simply tricks your brain into forgetting that it's tired. That specific trick is what makes caffeine a drug. In the world of science, a drug is any chemical substance with a known arrangement of atoms that creates a distinct biological effect when it enters a living organism. The feeling of waking up after a cup of coffee isn't a magical infusion of life force. It is the result of a physical, microscopic interaction happening inside your nervous system. For centuries, medicine was largely a guessing game. Apothecaries mixed raw plant extracts and bizarre concoctions, knowing that a certain syrup might reduce a fever, but having no idea how the chemistry actually worked. That changed in the early 1900s, thanks to researchers like Paul Ehrlich. He insisted that the mysterious effects of medicine were actually the result of conventional chemistry. Ehrlich realized that for a drug to have any effect at all, it has to physically bind itself to a specific part of the body. Think of billions of chemicals with very specific shapes drifting through your bloodstream. They bump against different tissues until they find a pocket on a cell that matches their own structure. Modern pharmacology is built entirely on this microscopic game of matching a chemical shape to a cellular target. To see this in action, we can look at the surface of a brain cell. It's covered in receiving stations called receptors, specialized proteins designed to catch chemical messages. Throughout the day, as your brain burns energy, it produces a byproduct called adenosine. This molecule is your body's natural signal for sleep. When an adenosine molecule drifts up to a receptor, it nestles perfectly into the protein structure. This interaction requires two things to happen. First, the molecule has to be attracted to the receptor and stick to it, a property called affinity. Once it's there, it has to actually trigger a change in the cell, which scientists call efficacy. Because adenosine has the affinity to stick and the efficacy to fire off a slow down message, it is what we call an agonist. That heavy, sluggish feeling you get late at night is just an internal agonist successfully turning on the signals that hit the brakes on your nervous system. So what happens when you drink a cup of coffee? You flood your system with a swarm of new molecules. By pure chemical coincidence, the edges of a caffeine molecule share the exact same structural shape as the adenosine that makes you sleepy. Caffeine has the affinity to slip right into the receptor, but it lacks the efficacy to trigger a response. It sits there, occupying the space, without ever sending a slow-down signal to the brain. Because caffeine takes up the receptor without activating it, we call it an antagonist. It's a silent blocker. With the caffeine molecules hogging the space, your natural sleep signals have nowhere to go. They bounce harmlessly off the occupied receptors, unable to deliver their message. The sleep signals are physically blocked. You feel alert because your brain is shielded from the chemical reality that it is tired. This same invisible geometry is what makes modern medicine possible. For over a century, people have used aspirin to stop pain. It works by blocking the specific chemical pathways that trigger inflammation in your tissue. Antihistamines work as antagonists, physically shielding your cells from the signals that cause a runny nose. Meanwhile, an asthma inhaler delivers an agonist, a molecule designed to stick to receptors and force tight airways to open up. Whether a medication is meant to start a biological reaction or stop one, it is playing the exact same microscopic matching game as a cup of coffee. Today, pharmacologists map the receiving stations throughout the human body, engineering specific molecules that fit into those spaces and change how our biology behaves. There is no magic in a pill. And there is no magic in an energy drink. Every time you soothe a headache or wake yourself up for an early meeting, you are witnessing the power of billions of tiny molecules finally finding their perfect match.